Alright, so we're going to look at section 8.3 in our Algebra 2 book. It's multiplying, dividing rational expressions. If you want the notes to follow along, I have them on my webpage. So you just go on there and print them out, so you don't have to write this out, or you can just write them out on your own notebook paper. So let's get started. We're just going to be simplifying these rational expressions and then, like it says in the title, multiplying and dividing them. So we're going to start by factoring the top and the bottom polynomial on this rational expression. So the top one, I notice right away that there's an x in each one. And so I'm going to factor out an x to start with. And that's going to leave me with x squared plus 2x minus 15. And then the bottom, I can factor that. That's going to factor into, remember this is just the opposite of foiling, so we're kind of unfoiling it. So I know it's going to be x and x, because we want it to multiply up to x squared. And then we want it to multiply to 3 for these numbers, so it's going to be minus 3 and minus 1, because they have to add up to minus 4. So if we FOIL this out, x squared, that's good, minus 1x, minus 3x, that'll give us minus 4x, which is what we want, and then plus 3. So that's what we're looking for. Let's factor the top as well, a little more. So it's going to be x, and then the top is going to be x and x. And then what numbers multiply to negative 15 that add to positive 2? So it's going to be plus 5 and minus 3. And then the bottom is going to be just like it was, x minus 1, x minus 3. So to simplify it, we have an x minus 3 on top, x minus 3 on bottom. Those can cancel out. So simplified, the answer is going to be x times x plus 5 over x minus 1. And that's it. It's really, that you just cancel out what's in common on top and bottom after you factor it. Now there's one small catch. We need to say the domain restrictions. So the domain restrictions. And this is what can x not be. So in this case, x cannot be 1, because if we put 1 in for x, you're going to end up dividing by 0. So x can't be 1. But it also can't be 3, because even though we canceled these out, you still can't divide by 0 up here. So if you ever divide by 0 throughout the problem at all, then x can't be that number. So x can't be 3 as well, because that would make this dividing by 0. So x can't be 1 or 3. Alright, so that's it for that problem. Let's move on to the next one. So now we're going to multiply these, and it's going to be the exact same first step. We're going to factor each of these 4 polynomials. So let's knock those out right away. So we'll factor the first one. I'm going to switch over to blue here. So this would end up being, we want numbers that multiply to negative 6 that add to negative 1. So negative 3 and positive 2. And then on the bottom here, we want numbers that they'll multiply to 14 and add to positive 9. So plus 7 plus 2. And then over on this fraction, we want numbers that will multiply to negative 7 that add to positive 6. So x plus 7, x minus 1. And then on bottom here, we want numbers that multiply to negative 3 that will add to positive 2. So it's going to be x plus 3, x minus 1. Okay, So to multiply these, we're going to multiply the tops across and multiply the bottoms across. And so it's just going to be, I mean, you're just going to essentially get rid of this multiply sign, and it's going to be one big happy fraction. So really what we can do then is just cancel stuff out that's on top and bottom. So we get x plus 2's cancel out, x minus 1's cancel out, x plus 7's cancel out, and we're left with x minus 3 and x plus 3. And those can't cancel out because they're opposite signs. You can't like cancel out an x or reduce the minus 3 and plus 3 to 1 and 1. That's not legal. You can't do that. So our final answer is x minus 3 over x plus 3. And that's it. We should probably list our domain restrictions. X cannot be, let's list out all the things that x cannot be. So it can't be negative 7. It can't be negative 2. It can't be negative 3. And it can't be positive 1. And once again, these are all the numbers that would make us end up dividing by 0, and that's a no-no in math. All right, we got 2 more problems. They're going to get a little hairy now. So what we're going to do here is we're going to factor all 4 of these polynomials, and then we'll talk about how to handle dividing a fraction with a fraction. So we'll just factor them right next to each other. So what I'm going to do first is I notice that all of these are divisible by 3, so I'm going to take out a 3. And we get x squared plus 2x minus 8 over, and then these are all divisible by 2, so I'm going to factor out a 2. We get x squared plus 4x minus 12. And then same thing on the bottom here. This one's, they're all multiples of 9. So we're going to get x squared plus 9x plus 20. And then down here, they're all multiples of 4. So it's going to be x squared minus 5x. Oops, I missed the 5 there. Minus 50. Okay, so let's factor each of these, and we can do that. I don't have enough room here, so we'll do that down below. So it's going to be 3, and then this one's going to factor into, let's see, we got to multiply to negative 8 and add to positive 2. So x plus 4, x minus 2. This one has to multiply to negative 12, add to positive 4. So it's going to be x plus 6, x minus 2. Alright. And then this one's going to be 9. Let's see, multiply to 20. Add to 9, so x plus 5, x plus 4. And then on bottom, this is what I'm going to have to think about a little bit here. We get multiply to negative 50, add to negative 5. So I'm thinking negative 10 and positive 5. X minus 10, x plus 5. Okay, so back in, I don't know, 3rd, 4th grade, you may have come across a problem where it was like 1/3 divided by, I don't know, 3/4. And your teacher probably taught you back then, if you're dividing fractions, the way to do that is you would multiply by the reciprocal. So we'd take 1/3 times 4/3. And we end up with, multiply across, we get 4/6, which is 2/3. So this is really what we're going to be doing on this problem. We're going to take this bottom, we're going to flip it, and we're going to multiply by the reciprocal. So let's give ourselves some room here. We're going to write the top again. In fact, what I'm going to do, I'm going to cheat here. I'm just going to copy and paste it. So write the top again. And then next to that, we're going to multiply by the bottom flipped. So I'm going to take the bottom here. I don't think I can do that. I'll just rewrite it. So we're going to go times, and then we're going to write the reciprocal of the bottom. So it's going to be 4 x minus 10, and then x plus 5. And on the bottom, now it'd be 9, x plus 5, x plus 4. Okay, so now it's just like the problem before. We've got a bunch of stuff on top, a bunch of stuff on bottom. We can start canceling things out. We've got an x minus 2 on top and bottom. We have an x plus 5 on top and bottom. We have an x plus 4 on top and bottom. So all we're left with is x minus 10 and x plus 6. And actually, we can start reducing some of these things. So 3/9 will reduce to 1/3. And 4/2 will reduce to 2/1. So after we get all of the things reduced and canceled out, we end up with, on top, we get 1 times 2, which is 2. And then there's an x minus 10 left. And then on bottom, 1 times 3 is 3. And there's an x plus 6 left. Okay, so that's it. We also need to state our domain restrictions, and this is where things are going to get a little bit complicated. Maybe not complicated, just kind of messy. So the domain restrictions are wherever you divide by 0, anywhere in the problem. So x cannot be 4, or sorry, negative 4. So x cannot be negative 4. It also can't be negative 5. It can't be 2. And it can't be negative 6. There we go. But we're not done. That's just for the final product. But if we go back up and look at our problem, it looks like, let me scroll up here. Looks like we also would be dividing by 10 here, and that would give us 0, so that's no good. And let's see, we're dividing by negative 6, we got that counted. 2, that's counted. Negative 5, that's counted. So it looks like we also have to include negative 10, or I'm sorry, positive 10, because that would make this one dividing by 0. So you have to go back up into the problem and look at, the original problem and determine, am I dividing by 0 other places, and those are also included in the domain restrictions. So another one would be positive 10. So we'll write that down. There we go. Okay, so that's it for that problem. So this is really enough information. If you feel pretty good about things, you can probably pause the video, or you can just stop it. But there's one more problem. This one's, it's really just a combination of the two before. So, I'll do this one, but if you feel pretty confident in what we've been doing, then you don't have to watch this part of the video. What we're going to do is we're going to factor everything like we did before. We're going to flip this thing, tack it on here, and then we have 3 parts that we can start canceling things out. So if you're good, the assignment should be on the note sheet on my webpage. So if you didn't print out the notes, go look at the note sheet, and that's on there. Otherwise, continue on and watch this part of the video. So I'm going to factor all these things, and I'm going to pause and factor them, and you guys should probably pause the video and factor them as well. I just don't want to have you sit here and watch me factor things. So go ahead and pause the video, factor them yourself, and then when I come back again, they'll be all ready and factored for us. Alright, we're back. I've got my polynomials factored. And so I also did a few more steps and I covered them up with a shade here. So what I did, I got these factored, and then the next step, we're dividing fractions here. So I wrote these in red. I'm going to flip these and multiply them. So I'm multiply by the reciprocal. So I have that down here. And all I did was I flipped the bottom. So now I've got the first fraction times the top of this fraction times the reciprocal of this, and we get this whole line of binomials down here. So let's figure out what that's going to end up being. And let's start canceling stuff out. So I see right here I've got an x plus 3, x plus 3. I've got an x plus 5, x plus 5. And x plus 2, x plus 2, x plus 1, x plus 1, x plus 4, x plus 4, and then what's left over is an x plus 3 on top and an x plus 4 on bottom. So our final answer here is going to be x plus 3 on top over x plus 4. That's what this simplifies down to. And then we'd also state our domain restrictions. And that's going to be a big slew of numbers. It can't be -2. Sorry, x cannot be -2. It cannot be -4. It cannot be -1. It cannot be -3. It cannot be -5. Now, some people might be tempted to say, well, that's everything from -1 to -5. So can I just say it can't be anything from -1 to -5? No, because it could be -1.5. So you have to list them out. You can't just list out a range. Okay, then we got to go back up and see if there's anything we're missing from the problem from before. So looks like we would be dividing by -1. We already have that covered. -5, we have that covered. -1, -3, -4, -5. So it looks like we've covered all of our bases with the domain restrictions. So the domain cannot be any of these numbers, -2, -4, -1, -3, -5, because if we punch those in, we would end up dividing by 0, and that's just no good. So our final answer for this one is x plus 3 divided by x plus 4. All right, and that's it.